This module talks about water resources. We're primarily talking about water resources in this unit. With water resources, we are going to exclusively discuss fresh water. Fresh water is a deep concern for all of us. Water has changed in quality, in quantity, and location over the last century plus, and it is becoming more and more difficult to manage water across our planet for human needs and ecosystem needs. So with that, we're going to talk about the geographic nature of this water, how it functions, and why we need to think about it a little bit differently as we manage it for ourselves and for the other organisms that this planet inhabits. So with water, we know that it's fundamental to life on our planet. I've got two images here. One is of the Phoenix, Arizona area. The other, the lower of the two, is of New Orleans. One of these areas has far less water than humans would like, and one has far more water than humans would like. Generally speaking, when humans are looking at a landscape and we're considering what we want to do on that landscape, we fall into almost two categories, almost exclusively with some variance. There's either more water than we want here or less water than we want here, and then we start to augment or manipulate the landscape in order to deliver water to where it isn't or to remove water from where it is. So in Phoenix, Arizona, we are removing water out of the Colorado River. We're impounding it in a few dams along that river, and from those dams we can measure out that water over time and deliver it across Utah, Nevada, Arizona, and Southern California before it exits out into the Gulf of Mexico. That is a function of a large landscape where over the last geologic period, there has been a deficit amount of water in that area, but humans want to live here and there are things that we want to do. And in order to manage the things we want to do, we need to deliver water to those environments. That's become a problem. In converse, places like New Orleans are areas where we've got far more water than we want. And in order to have a thriving city where we've got bayous and swamps and wetlands all around, and that the water table is at the surface, or in some cases above the surface of New Orleans, we've got to impound that water, keep it from those areas where the city exists or where we're going to have some agriculture, and divert it out of those environments. So two very contrasting environments. Ohio is somewhere in between. We've got some portions of Ohio where we wish we had a little bit more water, and some portions of Ohio where we wish we had a little bit less water. With that, we divert and we irrigate. So we're adding water to those places where we don't have enough water. And on a smaller scale, we will pump out water in those farm fields or those communities where there's some water that we don't have. But in either case, scale excluded, too much or too little for what we want over a particular point in time in a particular location. So we are managing our water conditions on a landscape by landscape basis, mostly with the inclusion of levees and dikes, as we have with New Orleans, to keep the water back away from areas. Or similarly, we're going to dike or impound water to create a large lake that we're going to be able to divert through a canal that water to places like Phoenix and Las Vegas to add water to their environment. I've included the term Central Arizona Project to this particular slide because the Central Arizona Project has made all of Arizona, for the most part, except for the high elevations to the north, viable and livable for the quality and the type of lifestyle that folks in Arizona have become accustomed to. So those same types of mechanisms in the Central Arizona Project are ubiquitous across other dry areas of the American landscape, to include parts of Texas, Oklahoma, Kansas, the Dakotas, certainly Nevada and Utah as well, and most of Southern California. So, with water as being fundamental to life, we know that water changes in volume over time. Natural climate change cycles operate on a variety of nested hierarchies, so we can get decade-long cycles where we get dry periods and wet periods. The 1980s and the early 2000s were dry periods. The 1990s and last decade were a little bit more moist. So we get those sorts of decade-long cycles. Across the United States, we are on a 200-year drought cycle that started about 30 years ago. So we know that within those 10-year dry and wet cycles that we are overall in a drying cycle that's going to predictably last for another century and a half, more or less. So we've got different scales on which we should be able to expect or anticipate moisture in an area or the lack of moisture in an area. With that, we've got shorter time frames that we're all more accustomed to. Here in the Midwest, in Ohio and Pennsylvania, we see high moisture environment times in the springtime, and in the fall, we get moisture deficit times in the winter and in the summer. So those are very easy to manage for, and we have become very, very good at that over many centuries. So humans, in order to accommodate for these cycles that we're familiar with, the annual cycles and the seasonal cycles, and now those decade-long cycles, we've constructed many water structures to keep places from flooding when we don't want them to flood. So we can put towns and communities in valley bottoms where an annual precipitation event would be naturally flooding that area. Or we're going to then create dams and canals, which are going to divert water away from those areas to other areas where maybe we don't get the type of water volumes that we want. So with water, as I said, nature doesn't see there being a deficit in water. The ecosystems that exist in a desert aren't starved for water. Each one of those organisms, whether it's a rattlesnake or a hare or a cacti or a creosote plant, all have genetic conditions that adapt to the moisture conditions that are intrinsically in each one of those deserts. The same condition for grassland environments, which are low moisture environments as well. All of those plants have root structures that allow them to access water during dry periods. All of those structures have leaves and bark and other external extremities that protect them when there isn't enough water and allow them to collect water when water is available. So there is no deficit condition there. The organisms have over millions of years figured out what they need to do in a genetic way, not cognitively, in a genetic way. They are adapted to that landscape. Likewise, those moist landscapes there's no excess water for those systems either. Those plants, likewise, are completely in tune with high volume moisture conditions and variable moisture conditions, and the turgor pressure that those plants produce because of the moisture that is there is necessary for those plants to exist. So there is no too much water in a bayou, in a swamp, in a wetland environment.